We are going to start looking at stars. I guess we've looked at the sun already, but we're going to start looking at other stars as well. So, question for today, why is it important to understand stars? All right. As you can see, there's a bunch of different types. They're different sizes, they're different colors, they're different temperatures, and we're going to get into why there are so many different types of stars. But today, we're going to look at why is it important to study them. All right. So if you guys could write this question down in your science journal, we're going to come back to this at the end of the day. Why is it important to learn about stars? If we were in class, we would end up plotting a couple stars on some graph paper, and by plotting these stars, you would get something that looks like this. And then I would ask, does anybody recognize that? And hopefully somebody in class would be bright enough to notice that there are 3 stars that kind of go in order right there. This is actually the constellation of Orion. And even within Orion, you'll notice that there are different size stars, there are different colors, they are different brightnesses. And if we wanted to actually count all of these stars, these background ones as well, instead of just those 12 points of light, there are millions or billions, depending on how far you zoom in. So of the main stars in Orion, there's 10 to 12. Visible stars that you can see with your naked eye, about 250. If you have a long exposure camera and you just train it on Orion and let it sit there, you can see hundreds or thousands. You can see hundreds or thousands. Hubble can see millions of stars within just the constellation of Orion. If you were to be able to take out all of the gas and dust in our galaxy, Hubble could then see billions of stars. And if you add up all of the distant galaxies that are in that area of the sky, you're getting into trillions or quadrillions of stars. And then if you go past like the visible universe, there would be even more. So it really depends on how faint do you want to get when you're talking about how many stars are there in the constellation of Orion. And now, the most astounding fact by Neil deGrasse Tyson.
What is the most astounding fact you can share with us about the universe?
The most astounding fact.
The most astounding fact
is the knowledge that the atoms that comprise life on Earth, the atoms that make up the human body, are traceable to the crucibles that cooked light elements into heavy elements in their core under extreme temperatures and pressures. These stars, the high mass ones among them, went unstable in their later years. They collapsed and then exploded, scattering their enriched guts across the galaxy. Guts made of carbon, nitrogen, oxygen, and all the fundamental ingredients of life itself. These ingredients become part of gas clouds that condense, collapse, form the next generation of solar systems, stars with orbiting planets. And those planets now have the ingredients for life itself. So that when I look up at the night sky, and I know that, yes, we are part of this universe, we are in this universe, but perhaps more important than both of those facts is that the universe is in us. When I reflect on that fact, I look up. Many people feel small because they're small and the universe is big, but I feel big because my atoms came from those stars. There's a level of connectivity. That's really what you want in life. You want to feel connected. You want to feel relevant. You want to feel like you're a participant in the goings-on of activities and events around you. That's precisely what we are, just by being alive.
going on with what Neil was just speaking about, let's take a look at where different elements from the periodic table, so the elements that exist in the universe, where do they come from? Obviously, the Big Bang had quite a bit to do with where elements come from. Hydrogen and helium were created during the Big Bang. In fact, almost all of the universe, all of the matter in the universe is hydrogen. It's 1 proton big. It is the simplest atom, and there was a lot of it created during the Big Bang. The heavy elements, things heavier than hydrogen and helium, and a little tiny bit of lithium that, decayed back down into hydrogen. The heavier things like carbon and oxygen, or, arsenic, or lead, gold, uranium, those all came much, much later. Taking a look at the periodic table, hydrogen, including all the hydrogen that is in every drop of water that you'll ever see, was created in the Big Bang. Every single atom was created during the Big Bang. Helium also was created during the Big Bang. So whenever you breathe helium in out of a balloon to make your voice sound funny, just know that you are breathing stuff in that was created 13.5 billion years ago at the beginning of our universe. Small stars, what do they create for us? If you remember, small stars actually take that hydrogen that was created during the Big Bang and they fuse it together into helium in order to release energy. And towards the end of a star's life, when you run out of helium and gravity pulls down a little bit stronger because you're not pushing out with fusion anymore, then you can start to make things like carbon. So if you have a small star, and one like our sun is actually considered a small star, by the end of their life they will have fused a bunch of hydrogen, but then also maybe up to elements like carbon or nitrogen. So when you take a look at the periodic table, the carbon and the nitrogen that are in living things, those can be formed in small stars. Big stars, stars that are much bigger than our sun, stars like the one above me, Betelgeuse, when they die, they make heavier elements, all the way up to, hopefully you remember, all the way up to lead. Once you get up to lead, you can't put out any more fusion energy, and so the star will collapse and die and be done. We'll get there when we talk about the lifetime of stars. But everything below lead can be made in a large star, in the core of a large star. So oxygen, sulfur, silicon, all things that you guys have in your body right now, calcium in your bones, those are all made inside of big giant stars as they are nearing the end of their life. The calcium that's in the milk that you are drinking was created at the core of a giant star like Betelgeuse. The iron that's in the hemoglobin that makes your blood look red, created inside of a star like Betelgeuse. So things that are in our body also created inside of stars. Much bigger stars than stars like our sun though. What about elements heavier than lead? What about gold? What about uranium? Well, if you are a supermassive star, once they have a core full of lead and they can't push out anymore, the star will collapse down on itself and basically rebound out. But that collapsing down pushes atoms together that wouldn't normally be able to go together, and you end up fusing heavy elements like titanium or uranium or gold. Even still though, all of these elements were created with the death of a star, all the way up to element number 92, which is uranium. Past 92, those are going to be man-made. Things like gold or the titanium in your eyeglasses, those are all created when a star goes supernova. Let's take a look at the top 10 elements in the human body. Magnesium, I'm just going to go through these quickly.
Chlorine, sodium, salt, sulfur, phosphorus, calcium, nitrogen, carbon, oxygen, and hydrogen.
You might think, why do you have so much hydrogen? Well, water. So the reason that we have so much oxygen and hydrogen is because we're mostly water. Really, the only element in your body that was not created in a star is the hydrogen. Every other atom that's in your body right now, as you're watching this video, was made inside of a star. When you ask that question, where did we come from originally? Well, think all the way back to stars dying and exploding and shooting their enriched chemical guts throughout the universe. As those things are flying through the universe, eventually big clouds of that are going to start condensing and coalescing and spinning, the planetary nebular theory that we learned about. Earth was formed. We came from elements here on planet Earth. Basically, if you go back far enough, every atom in your body, except for the hydrogen, made in a star. Made in a star like the ones that you see in Orion. In fact, Betelgeuse, being a red supergiant, is planned to go supernova rather quickly. When this goes supernova, when Betelgeuse goes supernova, it's going to spread out oxygen and carbon and heavy elements like gold and titanium into the space around it. And then maybe eventually there will be another star that coalesces some of that titanium from Betelgeuse. And billions of years from now, maybe there will be an alien wearing eyeglasses that have come from the exploding of Betelgeuse, a star that we can see right now with our naked eye. If you look at your car key or house key, maybe some of the metal that is in the key that you are holding in your hand came from a star that aliens billions of years ago were looking at, waiting for it to go supernova. Maybe that star was in one of their constellations and they had to go to astronomy class and learn about stars and how elements are created inside of a star. Maybe these atoms came from that star that aliens used to look at. It's kind of a cool way to think about the universe recycling itself. The crazy thing is, right in the center of Orion, there is the Orion Nebula with new stars that are currently being made. So we may be looking at some of these atoms being formed in these distant stars that one day are going to end up in the body of an alien. Back to Neil.
Recognize that the very molecules that make up your body, the atoms that construct the molecules, are traceable to the crucibles that were once the centers of high-mass stars that exploded their chemically enriched guts into the galaxy, enriching pristine gas clouds with the chemistry of life, so that we're all connected to each other biologically, to the Earth chemically, and to the rest of the universe atomically. That's kind of cool. That makes me smile. And I actually feel quite large at the end of that. It's not that we are better than the universe, we're part of the universe. We're in the universe and the universe is in us.